The forward lower lobe cargo door is located on the lower right portion of the forward fuselage. On February 29, 1989, United Airlines Flight 811, a Boeing 747-122, experienced a rapid decompression as it was climbing between 22,000 and 23,000 feet after taking off from Honolulu, Hawaii, en route to Sydney, Australia, with an intermediate stop in Auckland, New Zealand. The flight took off approximately 1:30 a.m. Honolulu Standard Time. The rapid decompression was caused by the opening of the forward lower lobe cargo door. Debris from the aircraft damaged the right side engines, portions of the right wing, and the right horizontal stabilizer. The flight crew initiated an emergency descent, turned 180 degrees, and proceeded to return to Honolulu. There were thunderstorms in the area that the crew had to avoid. Because of damage to leading and trailing edge flaps, the final approach speed of the aircraft was quite a bit faster than it would be under normal conditions. The aircraft touched down about 1,000 feet from the approach end of the runway and came to a stop about 7,000 feet later. An emergency evacuation of the aircraft was commenced on the runway.
Setting at 811 Heavy, we're at Mayday. We've got to come back. We had a bomb or something go off an airplane. We're taking a 180 and trying to get back to the airport.
United 811 Heavy, Honolulu Center, cleared to wreck Honolulu Airport. Say altitude now.
Riley. Yeah, we don't know what's going on. Looks like we've lost number 3 engine, and we're descending rapidly, coming back.
United 811 Heavy, roger. Keep center advised.
Mayday, yes.
Continental 10 Heavy, turn 30 degrees left, effective for inbound traffic.
Center, United 811 Heavy, yield a fix on us.
Affirmative, sir. I have you on radar.
Okay, it appears that we have lost number 3 engine, and we've lost. We're not getting full power out of number 4. We're not able to hold an altitude right now. We're dumping the fuel, so I think we're going to be able to hold an altitude here shortly.
9811 Heavy, roger. Show you 60 miles south of Honolulu at this time.
Roger.
United 811 Heavy, pilot's discretion descent to 4,000.
Okay, 4,000. We got a fire on the right side. We're on 2 engines now.
United 811 Heavy, roger.
Yep, fire on right. Hey, it looks like we got a bomb that went off on the right side. The whole right side is gone.
Approach.
He's on the ground, midfield, big hole in the right cargo door. Big hole, right forward cargo. He's on the ground, came in with 2 engines, and they're evacuating the aircraft now.
Okay.
No, everybody's just jumping out of the airplane.
This is an overview of the electrical and mechanical operation of the cargo door system. This depiction is highly simplified relative to the actual door control system. During normal operation, when the airplane is on the ground and connected to a ground power unit or to the airplane's auxiliary power unit, electrical power is supplied to the master latch lock switch, otherwise known as the S2 switch. When the S2 switch is closed, electrical power is further supplied to the cargo door external switch, which allows a ground crew to open or close the door. Closure of the S2 switch is achieved by contact with a latch sector, which, when unlocked, closes the S2 switch. When the external door control switch commands the door to close, an electrical command is transmitted through a series of switches and relays which are not depicted on this diagram. The door actuator motor becomes powered and through a series of mechanical linkages rotates the latch cams around the door latches, thereby latching the door closed. Though not shown here, power to the actuator motor is derived from the ground handling bus and is three-phase, 115-volt power. The motor itself, shown here in a highly simplified manner, is also controlled by a series of switches and relays, and drives a slip-clutch gearbox that mechanically operates the latch cams. Once the latch cams are properly positioned and the door is properly latched, the switch is depowered and the actuator motor shuts off. Finally, the manual door lock handle is moved to the lock position. Via mechanical linkages, this closes the vent relief doors and moves the lock sectors to lock the latch cams. Difficulty in moving the manual handle would indicate that the latch cams are not properly positioned and would prevent the vent relief doors from closing, thereby preventing pressurization when in flight. Moving the lock sectors also opens the S2 switch, removing power from the cargo door external switch. When electrical power is disconnected, either by disconnecting the ground power unit or the APU, the entire door electrical system is de-energized, and no electrical power is available to power the door system in either the open or closed direction. If the airplane is in flight, an air-ground switch de-energizes the door system and prevents electrical power from reaching the cargo door. For the scenario leading to the in-flight opening of the cargo door on United Flight 811, the NTSB postulated that at least two failures occurred that led to the door opening. The door was first closed, latched, and then locked in the normal manner. The latch cams were in proper position, the lock sectors were positioned to lock the latch cams, and the vent relief doors were properly closed. However, the NTSB surmised that the S2 switch had experienced a failure that remained latent for an undetermined number of flights. This failure allowed electrical power past the S2 switch, even when the lock sectors were moved to a position that should open the switch. Therefore, when the door was powered closed and the latch cams were driven to the latched position, electrical power was not removed from the S2 switch. Following the accident, chafed wires were found in the wiring harness, and the NTSB concluded that these chafed wires allowed a short circuit to occur between the S2 wiring and other wires in the harness, and led to power being supplied to the actuator motor. The short circuit, in combination with the failed S2 switch, allowed an unlatch command to reach the latch cams, driving the cams against the lock sectors, forcing them out of the locked position and leaving the door in an unsafe condition. The vent relief doors remained closed and the door itself remained closed, although it was no longer properly latched or locked. On the accident flight, all that was required was for the pressurization system to create a sufficiently large differential between the internal and external pressures to force the door open in flight. The NTSB concluded that the door could not have been powered open in flight and that it had been inadvertently powered open on the ground sometime between its being properly closed by the ground crew and engine start. This animation shows the latch cams rotating around the latch pins when the door is in the closed position and the latch sectors moving across the opening of the latch cams. Only the latch cams and pins on the door sill are shown in this rendition. There are also two midspan latches located on the forward and aft sides of the cargo door that rotate around two latch pins on the forward and aft sides of the door frame. There are a total of 10 latch cam pin combinations, 8 on the door sill and lower door frame, and 1 on each of the forward and aft sides of the door. After completion of the latch cam, rotation power is cut from the door system. The final securing operation is the movement of the master latch lock handle to the closed position. This manually moves the latch sectors across the opening of the latch cams through linkages attached to the master latch lock handle. Also linked to the master latch lock handle are the two pressure relief doors, which close when the master latch lock handle is moved to the closed position, thus providing an indirect indication of the latch sector position. The pressure relief doors are designed to relieve any residual pressure differential before the cargo doors are opened after landing and to prevent pressurization of the airplane should it depart with the cargo doors not fully secured. This animation demonstrates what is supposed to happen when the master latch lock handle is moved to the closed position. When the master latch lock handle is in the open position, the latch sectors are in the retracted position. In this position, one of the latch sectors exerts pressure on the S2 switch. This establishes electrical control power to the door as shown by the orange color on the switch wiring. This allows power to the actuators on the door. When the master latch lock handle is moved to the closed position, the force on the S2 switch is relieved as the lock sector with the S2 contact moves across the opening of the latch cam. This action results in the removal of power to the door, as shown by the white color on the switch wiring. This animation shows what is conjectured to have happened with UAL Flight 811. When the latch sectors are moved to the closed position, power to the door remained. This is depicted by the orange color on the S2 switch wiring. The most probable scenario is a short circuit in the cargo door circuit that led to an uncommanded electrical actuation of the latch actuator. Since the latch sectors were made of aluminum, they were no match for the steel latch cams. The latch cams rotated to the nearly open position, deforming the latch sectors.